So if you actually wanted to build this, you have to implement an algorithm for doing it. Now I'm going to tell you, I took this algorithm from, I think, Derek Hoyam's slides. They're on the web that he took from somewhere else. So I don't know for sure that this algorithm is the one they use, but it sounds pretty good. All right, it's similar to what you would do. So first thing you do is you project out these dots and you just detect them. So you detect these speckles and you label all of them as unknown. I don't know their depth. Now what you start doing is you randomly select a dot that's labeled as unknown. And then you take this windowed search, all right, doing a normalized correlation and along a scan line. That is, I really should say along an epipolar line. I know exactly where to look, okay? And I check for the best match. And by the way, I have to make sure that that best match is good enough. If that best match is not so good, I mark that dot as invalid and I start looking for new dots again. But if my first match is really good, I start doing what's called region growing. I start looking around that neighborhood for matching other points against the known pattern, okay? Oh yeah, by the way, what am I correlating? I know the pattern I'm projecting. So I've got my little local pattern of what's called pseudo-random speckle points, and I just correlate them around. And so pixels nearby are added to a queue. For each pixel, I initialize its offset, looking for it from the one I just had. I search around a little bit, see if I find a good enough match. If so, I label it as matched with its offset, its disparity, and then I look for its neighbors and I add them to the queue. And I stop doing that when that queue is empty because I finished using this anchor point, and I go back again and I reinitialize, I pick another point and I stop when all the points are labeled as with a known depth or marked as invalid. So what makes that work is that I have this pseudo-random pattern, so any little patch can't be matched everywhere, but is matched sort of just in one place well along that epipolar line. I know those patterns, and so I can just drive that search very quickly.